Hello students, in my previous video I already discussed about gravitation chapter. In that we already discussed gravitation, universal gravitational law, relation between acceleration due to gravity and gravitational constant. Then we discussed about escape velocity, we discussed about time period of a satellite, and we discussed about acceleration due to gravity g, how it varies from Earth's surface and below the Earth's surface. Then we discussed about weightlessness, isn't it? So today in this video I am going to discuss with few problems which is related to universal gravitational law. Remember, first problem, very simple problem. So what is that problem? Calculate the force of gravitation between the Earth and the Sun. I think these type of problems you already done in class 9th. Okay, so similar problem. I selected here. See, Earth mass is given, Sun mass is given, distance between Earth and Sun is given already. D is given, M is given, small m also given. So why I written here capital M and small m? Because this Earth has smaller mass, then Sun has larger mass, so capital M, this is small m. So you can write in another way also, m1 m2 also. That is left to you. Just go for that one also. The next one, gravitational law, what it tells, F equal to gmm divided by d square. So substitute, all things are given here, just substitute everything. So once I solve powers, it will gives you 10 raised to 21. Once it goes numerator, it becomes minus 10 raised to minus 21. After solving this power, I can get this much. What is that? 10 raised to minus 20, 10 raised to 21 plus 21. After solving this, you will get 35.6, or you can write 3.56 into 10 raised to 22. Hope you understood. So this much of force of attraction will be there between Sun and Earth, so according to this data. So next one, see, a stone is released from top of a tower. Let me to draw one diagram for your convenience. Let me to write like this. So this is the tower. Stone is released, so for example from here itself. So this is the initial, and this is the ground, this is the final position. So remember, from here I already released, means before going to release, u will be 0, initial velocity will be 0. So u will be 0, that is initial velocity. Then what is the top of the height of the tower is given, that is 19.6 meter. Calculate its final velocity. I want v is how much. Once I know s or h, that is 19.6 meter, which formula I have to use? What is acceleration here? Acceleration due to gravity, that is a we have to take it as g. Why? Because this is freely falling, I can't say a acceleration, I have to write what? Acceleration due to gravity. So that's why, so formula, by using formula, what is that formula? V square, which is equal to u square, minus 2 into g into s. Or you can write in other words, you can take it as plus or minus, that depends on gravity. You can write v square minus u square, which is equal to 2 into g into s. So this is towards the ground, you have to take it as plus. Okay, that depends on, okay, at what manner object is moving, by the okay, either it is moving downward direction or upward direction, that depends. So plus and minus sign. Okay, so let me to write directly plus. Okay, right. Next one, here u means 0, so which is equal to 2 into, so what is this, 9.8. G value we already know, S is nothing but 19.6, so V square is 2 into 9.8, okay, into 19.6. V means 2 into 9.8 is nothing but 19.6 into 19.6. Can I write square? Okay, V square is this much. V is nothing but 19.6 meter per second. So this much of velocity requires, okay, before touching the ground. This is the final velocity. This is the final velocity. At this velocity, that particular stone will, okay, reaches towards the ground. Okay, this is the way to solve any problems. Hope you understood. Okay, it is towards the ground, so I have to take it as plus. Away from the, okay, ground, you can take it as minus. Okay, yes. Hope you understood these things. Okay, simple problems, just proper formula you have to use with the proper, okay, notations, and simplification is required, and final answer with proper unit, that is very very important. Okay, final answer also very important along with units. Without unit, that is meaningless, remember. Okay, yes, yes student. So next problem, problem number 3. Remember, this is also simple. Neglecting air resistance, find the minimum velocity of a body must have in order to escape from the earth. We already know escape velocity means minimum velocity is required to escape from earth's gravitational field. Okay, so that minimum velocity itself is called, okay, escape velocity. So we know formula, we know that escape velocity, that is, you can, let me to write here, square root of 2 into g into r. See, here E denotes escape velocity. Okay, so let me to write here escape velocity. Simple. Okay, formula 2 into g is 9.8. Okay, or they already given, let me to write that only. So then r for earth, that is 6370 kilometer. So 1 kilometer means 1000 meter, or 1 kilometer can also be written as 10 raised to 3 meter. So into 10 raised to 3 meter. Okay, so it is nearly, it will gives you, okay, 11,100 and, okay, 79.4 meter per second. Or if I want to convert this in terms of, okay, meter per second to kilometer per second, okay, let me to write one more step. So 11.18. So 179 is there. So if I make it round up, so 7 is greater than 5, so you can write it as 11.18 kilometer per second. Yes. Okay. Hope you understood. Simple formula, just substitution is required and proper units. Okay, I already converted here meter per second to kilometer per second. So this is in terms of meter, 11,179.4. So we can write it as 11.18. Hope you understood. Yes. Okay, so let me to solve one more problem. Okay, so this is the problem number 4. Yes, find the mass of the sun if the radius of the earth orbit is given, gravitational constant also given. Find the mass of the sun. Yes, we already know earth orbit is given. Yes, radius is given. So radius is how much? So earth orbit means this is called r. R is how much? 1.51 into 10 raised to 8 kilometer, or you can write kilo is there. So 1.51 kilo means you can write in this way also, into 10 raised to 3 meter. So in other words 51 into 10 raised to 11. So you can make it as easy way. So it is better to simplify. G value is given in problem itself, 10 raised to minus 11. SI unit is Newton meter square per kg square. Okay, we already know 1 year is required for earth to revolve around sun. So T is nothing but 1 year. So 1 year means 365 days. 1 year 365 days. In 1 day 24 hours. In 24, then 1600 seconds. So you will get, this is if I substitute this, let me to calculate first by using calculator. Yes, I got this much. Into 10 raised to 6 I can write seconds. So 1 year can be converted into seconds. So 1 year 365 days, 24 hours, then 3600 seconds. Then by using formula, we know one formula. What is that formula? T equal to 2 pi square root of r cube. Just refer my video, what I given in that video, time period of a satellite, or planet, whatever it may be, the time period. So the same formula I have to use here. M means mass of the earth, M means, or you can say here they given sun, it is not mass of the earth. Small m means mass of the earth. This is capital M, sorry, this is capital M. Let me to write correctly, mass of the sun. Now squaring both sides, let me to write here. Squaring both sides. After squaring, what you will get? T square equal to 4 pi square. Square root and square will goes. What remains? R cube G into M, capital M. So but I want mass. Mass is nothing but what? 4 pi square R cube divided by, okay, g into t square. So this is 4 into 3.14 square is there into 1.51 into 10 raised to 11, okay, cube r cube, that is whole divided by, okay, 6.67 into 10 raised to minus 11 into, this is 31.54 into 10 raised to 6. So remember students, finally you will get, just try to solve, okay, independently. You will get this answer 2.04 into 10 raised to 30 kg. 2.04, okay, into 10 raised to 30 kg. Okay, so just try yourself, you will get same answer. Okay, this is the exact answer what I written. Okay, yes students, let's move to the last problem of this video. Calculate the gravitational intensity at the surface of moon. So given quantity, mass of the moon is given 7.34 into 10 raised to 22 kg. Next, radius of the moon is given 1.74 into 10 raised to 6 meter. Next, gravitational constant 6.67 into 10 raised to minus 11 Newton meter square per kg square. But remember, just try to understand, here they asked gravitational intensity. What is the meaning of that? Let me to write here only, so it will be easy to understand. Okay, so gravitational intensity is nothing but it is the acceleration due to gravity on the moon. So moon they told, okay, this on the moon. So then how can I write, what is the relation? We know one relation between g and g. What is that? G m by r square. But in this case we want, okay, for moon I have to apply this for moon. How can I write? Gm, this is for moon, gravitational constant is constant for everything. Okay, this is for moon, mass of the moon, then radius of the moon, which is equal to 6.67 into 10 raised to minus 11 into 7.34 into 10 raised to 22 whole divided by 1.74 into 10 raised to 6. Yes, let me to calculate myself. Just try rm, sorry, this is r square, so okay, square is there, sorry for that. Okay, what you will get, 6.67 into 10 raised to minus 11 into 7.34 into 10 raised to 22. Okay, after solving this you will get answer, just check, 1.62 meter per second square. Why? Because this is acceleration due to gravity. You will get this much, 1.62 meter per second square. This is the acceleration due to gravity, or you can say gravitational intensity on the surface of moon. Hope you understood students. Just try it once again. Okay, try to solve independently. Okay, so can I stop here? Okay, thank you.